All right, so number four. All right, we're continuing from our last video. Question four says the map below shows three locations labeled A, X, and B on the Earth's surface. All right. And so it says which table correctly indicates the solar times at locations A and B when it is noon at location X. When it is noon at location X. All right. So it's something to keep in mind. So we know at location X, it is 12 p.m. Okay. That's what we do know. Now, what we also know is each box that we see here is 15 degrees wide. Each box is 15 degrees wide, right? So because each box is 15 degrees wide horizontally, because it's 15 degrees wide horizontally, that lets us know that it's also equal to one time zone. Okay, it's also equal to one time zone. So that means each horizontal box is equal to 1 hour. And so I write that here, right? So each horizontal box is 15 degrees wide, which is also equal to 1 hour. All right, keep that in mind. Now, the next thing that we have to also remember is when you head to the east, right? Hear that rhyme? If you head to the east, time increase. Have you ever heard that rhyme before? If you head to the east, time increase. And if you head to the west, time gets less. All right. If you head to the east, time increase. If you head to the west, time gets less. All right, let me just fix that arrow. All right. If you head to the west, head to the east, time increase. So if it's 12 p.m., right, then for A, I'm going to head to the west backwards. Let's see how many times I go backwards, right? So I go backwards 1, 2, 3, 4, 5, 6. So because I went 6 time zones back, right, that means I'm going 6 hours back. So 6 hours before 12 gives me A to be 6 a.m. All right. Now, what about B? Now, B, 1, 2, 3 hours. So because I went 3 hours forward, right? 3 hours past 12 p.m. would make B 3 p.m. And so, therefore, the correct answer is definitely going to be choice. Here we go. Choice B. All right. So you have to remember when you're heading to the east, time increase. When you head to the west, time gets less. And every 15 degrees is equal to 1 hour apart. All right. So the correct answer is choice B. Base your answer to the following question on the passage and map below. The map shows sections of the Atlantic Ocean, the Caribbean Sea, and the Gulf of Mexico. In 1641, the crew of the ship Concepcion used the sun and stars for navigation. The crew thought that the ship was just north of Puerto Rico, but ocean currents had carried them off. The ship hit a coral reef and sank off the coast of the Dominican Republic. The X on the map marks the location of the sunken ship. All right. What is the approximate latitude and longitude of the sunken ship? All right. So first things first, here's just some clues that I just see. Okay. One of the clues that I first see is I see Florida, right? Why is Florida important? Because of the fact that Florida is located above the equator, right? Florida is above the equator. Why is that also important? Because of the fact that it makes all of these latitudes have to be degrees north. That's number one. So all of these latitudes have to be degrees north, right? So 21 degrees north, 24 degrees north. Oops, sorry. 18 degrees north, 15 degrees north, 12 degrees north. That's the first thing. These are all degrees north. All right. Now, the other thing too is I see Florida, right? And that Florida represents the US. What do I know about the US? The US is located on the west side of the world. And so therefore, I know that this is also, all of these here are degrees west. Let me change the color so that way we can best represent. Here we go. So all of these longitudes, they're all degrees west. All right, so that's something to keep in mind. All right. Now that I know this, what does that lets me know? If I'm operating with latitude degrees north and I'm operating with longitude degrees west, my answer has to be degrees north and degrees west, right? That crosses out choice D because I see degrees south. That crosses out choice C because I see degrees south. That also crosses out choice A because I see degrees east. When we said Florida, Cuba, Haiti, Dominican Republic, they're all located on the west side of the world. All right. If you're on the east side of the world, the question you got to ask yourself is, are you around Africa or passing Africa? Right. If you're not passing Africa or around Africa, then there's a very good chance that you are just on the west side of the world, right? If you're in Africa, or at least most of Africa, and passing Africa, right? Just talking longitude wise, then there's a very strong chance you're on the eastern hemisphere, right? The eastern part of the world. So with that being said, our correct answer is going to be choice B. And that makes sense because 20.5 is located around here, right? And 70 degrees west is definitely located around here. All right. Number 6. Number 6 says, from Utica, New York, Polaris is observed at an altitude of approximately what? So we have to remember your altitude of Polaris. I've been writing this time and time again. Your altitude of Polaris is equal to your latitude. So that means we have to first find what is the latitude of Utica, New York, all right? Well, anytime we get any city that's from New York, we looking at one page of the reference tables. What page, everybody? Page 3. Page 3. And we're looking for Utica. So once we find the latitude for Utica, we're going to find the answer for the altitude of Polaris. So you ready to take this journey? Let us go. Let's go, let's go, let's go. So Utica, where we at? Where we at? All right. So Utica is located right over here, okay? And when I'm looking at the latitude, remember, all of these 40s numbers, they are all latitude. And New York is degrees north because it's above the equator, right? We are not located below the equator. We're located above the equator. So what's my latitude of Utica? All right, I'm going to draw an arrow. And basically, if I was just to give my estimation or rounding, Utica has a latitude of 43 degrees north, right? Utica has a latitude of 43 degrees north. Why is that important? Because now when I get to my question, right, I get to my question and I'm looking, here we go, boom. So if Utica is latitude is 43 degrees north, my altitude of Polaris just has to be 43 degrees. All right. That is your altitude of Polaris. All right. Your altitude of Polaris is just 43 degrees. It has the same number as the latitude. And so the best answer is going to be choice A, 43 degrees. All right, number 7. Number 7 says, the diagram below shows an observer measuring the altitude of Polaris. They say that Polaris is 20 degrees above the horizon, all right? So where do we see Polaris? We only see Polaris at or above the equator. We only see Polaris in the northern hemisphere. In the northern hemisphere, that is the only place where we see Polaris, right? And because they're asking for the latitude, right? Well, because we're asking for the latitude, we only see it in the northern hemisphere. That means we're not going to see it anywhere below the equator. So what options can we cancel out? We're not going to see it for choice D. We're not going to see it for choice B. Why? Because of that degree south. You cannot see Polaris if you have a latitude of degree south. So the answer either could be choice A or choice B. Now, what did we say? The altitude of Polaris is equal to your latitude. So that means that if Polaris is 20 degrees, my latitude is going to be 20 degrees north. The altitude of Polaris has the same number for a location's latitude, and that's why the correct answer is choice A. Hopefully we're able to see the pattern between altitude Polaris and latitude. Number 8 says Earth's approximate rate of revolution. This is just something that you need to know. The rate of revolution is 1 degree per day. All right, 1 degree per day. Remember, revolution talks about, right, if this is my sun and this is my earth, right? Revolution talks about, right, going around something. So that means, right, revolution is the earth going around the sun. That's what revolution is, and it takes 1 degree per day. Number 9 says the diagram below represents the apparent changes in the direction of swing of a Foucault pendulum, all right? This apparent change in direction of swing provides evidence that the earth what? All right, there's one main purpose for the Foucault pendulum, right? When we see it in reality, the word apparent means like appears to be, right? It looks like it. So it looks like the pendulum changes directions as it swings back and forth, right? It looks like it, even though in reality it does not. The reason why it looks like this is because it shows that the earth rotates. The earth rotates. That's the whole purpose of the Foucault pendulum. It shows, it proves that the earth rotates. What's another word for rotate? Turning. And so that's why the correct answer is choice D. The Foucault pendulum provides evidence that the earth turns on its axis. All right, number 10. Number 10 says the diagrams below represents constellations seen by observer in New York State facing south on midnight and January 3rd. All right. Remember, the word constellation means what? Constellation means is just a group of stars. It's a collective group of stars, right? That makes a pretty unique symbol, right, in the sky. So it says, which motion causes the observer to see different constellations at midnight on July 7th and midnight on July 3rd, right? What is the reason why we see different constellations? When we look at the nighttime sky in July, I see Sagittarius, Scorpius, I see Aquila, right? I see Lyra. However, when it is January 3rd, I don't see Sagittarius anymore. I don't see Aquila. Now I'm seeing different constellations, right? Orion, Canis Minor, Gemini, right? What is the reason why I'm seeing different constellations on different points throughout the year? The reason being is because the Earth revolves. It is all about the Earth's revolution. That's what it's all about. It's about the Earth's revolution, not the stars' revolution, not the constellations' revolution. The reason why we see different, keyword is different constellations, is because of the Earth's revolutions. All right? That's why the answer is choice B. All right, so this question says, a camera was placed outside at night and pointed directly at Polaris and several other stars. The lens was kept open and a time exposure photograph was taken. The diagram below represents that photograph of Polaris and star trails with an angular protractor to measure apparent motion. All right, so there's a device that was placed in order to track how stars are moving during the night. All right, so the question says, how many hours was the lens kept open to create the star trails in this photograph? So we're seeing 6 different star trails, all right? Six different star trails. Star Trail 3, 5, Star Trail 6, Star Trail 2, Star Trail 4, Star Trail 1, all right? So one thing that's going to help me is that I need to know how many degrees, right? How many degrees did each of these star trails move? How many degrees did each of these star trails move? Okay. Well, let's focus on Star Trail 1. Star Trail 1 went from 30 degrees to 90 degrees. Went from 30 degrees to 90 degrees. That looks like it traveled 60 degrees, okay? Star Trail 4 went from 300 to 360. That looked like it traveled 60 degrees. Star Trail 2 went from 270 to 360. That looked like it also traveled 60 degrees. Star Trail 6 went from oh, there we go. Sorry, new color. 210 to 270. That looked like it traveled 60 degrees. Star Trail 3 went from 180 to 240. That looked like it also moved 60 degrees. All right. And Star Trail 5 went from 120 to 180. That also looked like it moves 60 degrees. So are we seeing the pattern that every star trail moved 60 degrees? Okay. Now, how many hours does the Earth rotate? The Earth rotates every 15 degrees per hour. That means everything in the sky that we see generally is moving at 15 degrees per hour, right? So if I know that everything in the sky moves at 15 degrees per hour, when something is moved 60 degrees, how can I find out how many hours that it took, right? So 60 divided by 15 gives me 4. And so that lets me know that for something in the sky to move 60 degrees, and everything's moving at a rate of 15 degrees per hour, that means that it took 4 hours for the star to move 60 degrees. And that's why the correct answer is choice D. There you go. Number 12. Number 12, base the answer to the following question on the latitude and longitude system shown below. The map represents a part of the Earth's surface and its latitude, longitude coordinates. Points A through F represents locations in this area. And so the question says, as a person travels from location B to location E, the observed altitude Polaris will do what? All right. Well, what do we always say? What have I been saying this entire video? Your altitude of Polaris is equal to your latitude, right? Your altitude of Polaris is equal to your latitude, right? So if my latitude changes, my altitude of Polaris changes. When I travel from B to E, right? At B, my latitude was 60 degrees north. At E, what is my latitude? Still 60 degrees north. Did my latitude change? No, it did not. So if my latitude did not change, that means my altitude of Polaris did not change either. All right, it didn't change either. So what happens as a person goes from location B to E? Only thing that changed was the location's longitude. But if the latitude still stays at 60 degrees north, then what are we talking about? It stays the same. Choice C. All right, everybody, we made it to the last question, question 13, and it says, let me zoom this up so that way you can see it. All right, so the diagram below shows the apparent path of the sun as viewed by an observer at a certain Earth's location on March 21, right? And so it shows us the path of the sun traveling throughout the sky. All right. Now the question says, the sun's apparent path in the sky is caused by the blank blank that occurs at 15 degrees per hour. We got to fill in the blank. 2 words. Well, we know that the sun's apparent path, right? Is the sun in reality actually moving? No, it is we, right? The inhabitants of the earth, right? That is moving at a certain pace, 15 degrees per hour. What causes the sun to move throughout the day? To look like, keyword apparent, to look like it moves throughout the day is because the earth is rotating. Otherwise, right? Because the Earth's rotation. We see the sun moving because of the Earth's rotation. And so that's why the sun's apparent path in the sky is caused by the Earth's rotation that occurs at 15 degrees per hour. That is the end of our video, all right? Please make sure that if you want to review, especially for my class, make sure that you are subscribing, all right? You'll be updated for more videos. Other than that, people, have a wonderful, blessed day. Take care, everybody. We're going to make it.